Hello. Okay, yes, I believe we are on live. All right, hello. I was going to welcome to your weekly webinar number 11 with me, Michael Floyd. I am your mentor and your mentee. You learn as much from me as I learn from you. All right, so we are way past the starting point. We are way past the middle. We're looking towards being the end of this narrative degree. So that means who's going to finish, who's going to stick it out. A lot of you still have not completed the first project, which is very unfortunate because I'm looking forward to seeing all of you graduate. Now, it is still possible to graduate even if you have not completed the first project. What you need to do is get on the ball. Do not waste any time. You might have to sacrifice much things in order to get this completed. Like I said, we are in a state of emergency, even for the ones who have only completed the first project, have not completed the second project yet, right? So there is not much time, even with the second project not being completed. Uh, and one thing, shout out to Wenji. He completed his second project. So now we have two people, Wenji and Danny, who are going towards the third project and doing the third set of lessons. And I'm hoping they can stay on pace and continue being um, role models towards everybody else in this narrow degree. All right, like I say in every lecture, the money is already spent. For those who are behind, I would say 2 or 3 hours a day hopefully catches you up if you continue to do this. Uh, and every time you spend time doing these nano degrees and doing the project, why don't you just write on Slack what you were doing to help other students know that, hey, you're working too. What are you working on? What questions do you have? Right? Use these Slack channels to ask questions. Don't try to do this alone. This will be a lot easier done if you do it in a group. And like I said, every time we have three types of students. None of us are student A. We all have responsibilities. We fall in a category of B and C, where you have work, where you have school, and where you have a family that interact with you when you are trying to complete this. And student B, what he does is he drains everybody around him in order to complete this. And student C follows his schedule, right? We need to be more like student B and less like student C. All right. So to get down to what we're going to cover today is dimensionality reduction. And I would say dimensionality reduction is the second step when you are analyzing a data set, right? The first step is, obtaining the data and correcting for errors, like missing data. And I would say after that, then you are left with what you are going to do as far as dimensionality reduction. We have been given a huge data set and have no idea what to do with it. What I would do is I would start the screen sharing right now. One second. All right. So, like I was saying before, after you obtain the data and the curse of dimensionality, okay. So, what is the curse of dimensionality? So, the curse of dimensionality pretty much states, with more and more features you have, the uh, harder it is to get a good performance out of whether you are clustering or whether you are doing some sort of supervised learning, right? Your model has to extract information that is valuable from a lot of different features that may have invaluable information. So in order for your model to work around that, it has to work a lot harder. Uh, and the smarter thing to do, of course, is to um, reduce the number of features. So you have as little features and the most important features, and that's what the cursive dimensionality states. It's, the more and more features you need, more and more features you have, the more and more amount of observations you need in order to compensate for those features. So as you can see, a one-dimensional feature space, 5 data points. These 5 data points might be able to uh, explain this one feature, and but with 2D, you have 25 different data points, and 3D, you have 125 different data points. And so as you can see, this is an exponential growth in the amount of data that you might need in order to better explain the model given the number of features you use. So the point of dimensionality reduction is to decrease the amount of features using different ways. And there are 3 types of dimensionality reduction. And of course, the results have a finalized data set ready to be analyzed. That's after you take out the outliers. So finalized data set, then whatever outliers possible, and then ready to be analyzed. And there's 3 different types: feature selection, feature extraction, and feature transformation. I usually do it in that order, actually, when I am using dimensionality reduction. But feature selection relies on data exploration, data visualization, and domain knowledge and intuition. So, data exploration. What data exploration and visualization is to look at the data and explore exactly what these variables are showing you as far as mean, deviation, whether they are normalized or not, comparing variables to variables, and for exploring the data, visualizing data through different charts or metrics makes it a lot easier to have develop inferences on it and whether you need it or not. And it's not just the visualization, right? So you are able to also do metrics. So, for a bivariate analysis, that means analysis between 2 different features. What you can do is you can see if they're how correlated they are. Of course, there's different correlation metrics, and for univariate, like I said before, the box plots work. For categorical or continuous, and you can see if they're normalized or not, and all those type of things will help you uh, ensure exactly what you're looking for as far as different relationships between 2 features, multiple features, or just looking at what the feature represents in itself. And based on that, what you should do is decide on, hey, do I need this feature? If they are related, what are the next steps to go towards this, and whatnot. So, and I have several papers showing exactly what you need to know as far as when you are doing this dimensionality reduction uh, for every step. And I would like to show you some examples of my work and what I did. So this is what I did during my research assistantship for my master's program. What we did is we had exome chip data from RNA from different people in the uh, that were a part of the different people that were a part of the study taking place about renal failure, kidney failure. And so we had 233 subjects, and from this RNA data, we had close to 250,000 SNPs. And, as you can tell, the amount of people to amount of features is significant. And this is where domain knowledge comes in, right? So um, you have to examine many different things. The quality control was just making sure the sex was correct, the no sample mix-ups, because based on what we believed and who we believed to be related and not related, as far as what the people have told us, we could then see if there were any contaminations or errors, and sometimes people were sampled twice. So that was making sure that. But the big thing is domain knowledge, right? So we can remove the ones with the missing data and monomorphic, and being able to use domain knowledge brought down close to 250,000 to less than 60,000, which is a 75% decrease in the amount of uh, features, which is a lot. Still many features, but more expert analysis and what was believed have affected a certain place in the exome from previous studies will also be examined, and different things will help. And different things will help even bring this number down after I finished and gave them this data. And here's another example. This was during my final project for the machine learning engineering nano degree. And what I did is I wanted a model that would predict the graduation rate and the retention rate of different universities. So retention rate is the amount of first year, first time students who continue at that school next year. So these are, 18, 17-year-olds, the percentage that actually continue and go on to the next year. That, that tells you a lot about the school and perhaps these students as well, right? And for a parent or student who's looking into school, that's something that, you might look at heavily is, hey, what are the chances that I'm going to be returning next year? Looking at just what other students have done. And graduation rate is percentage of a school's first time students who complete their program within 150% of the time the program is allotted. So if you're in a 4-year program, graduation rate, if you complete in 6 years, you are a part of the percentage who have completed it. So that's you have to be at the school for the entire time as well. So uh, looking at graduation rate and retention rate for anybody who's looking at schools is very important. And what I took was a data set from the Department of Education, and from that data set that had many different variables. A lot of variables were left empty. Actually, yeah, as you can see right here, more than 1,700 variables for 7,800 institutions. And from domain knowledge, from looking at what these variables are telling you, whether it be significant in respect to graduation rate and retention rate, the covariance between these variables, looking at the means and medians of different things that might make a difference, such as using SAT average um, admission rates, seeing if there's any variance between those, right? That's what I was saying about the bivariate analysis. So just using principal code, we'll get to that later. But yeah, so this is the final project I did for the machine learning engineering nano degree program. And if you look at this, it's a very great example on data exploration and dimensionality reduction from 1,700 variables. I'm not going to talk about that yet. Oh, and Spotfire. So tools that help. Hold on, let me just look at it. So Spotfire is a tool similar to Power BI or Tableau, that will allow you to visualize data with interactive charts and visualizations. So in regards to Python, just making a chart is fine, but if you could change the chart and do interactive things and just switch variables here and there, um, it makes your life a lot easier. It also helps when you are explaining to a boss or a coworker what you were seeing and what you were doing and the reasons why you're doing and analyzing the data. Most people prefer charts and visualizations as opposed to just reading papers or different things. So this is actually I put a whole bunch of different slides together from a whole bunch of different things I did when I was working as a data scientist. But this is, on performance as far as a truck and looking at how a truck or a person would a driver from a truck. So this is him starting off the day driving, his idling time and his safety inspections, and yeah. So this is just an example of how you can look at a visualization and then a manager can tell how this driver is doing, the comparison between two drivers. All these things are things you can change. The dates that you want to look at the driver for. Uh, so all the performance indicator, the key performance indicators that you want to look at, all these things are things that you can change easily by just clicking. And this is what a visualization tool like Tableau or Power BI. This is Spotfire. And Spotfire in the background, you can do many different things, and it runs in the background. Uh, uh, a lot different background metrics are performed using R. So if you are comfortable with R, Iron, Python, and JavaScript, you could pretty much make this thing do anything you want. And that's the cool thing about it as well. So here, just show you this is going to be lab. This is the what I did as far as if a manager was looking to drill in a new location. So we have this formation right here that is in North Dakota that has oil. And here are the rigs that have already been drilled. Let's say I wanted to drill a new rig in this location. What I can do is I can place a bubble, and around in this bubble, I determine, hey, how long in how long did it take to drill to that depth, and also the um, depth until I struck oil in that location. And you can compare what's in the bubble, which the green tells you if it's in a bubble or not, and the stars or rigs that I picked that that are supposed to have similar backgrounds. So you compare what's in the bubble to what's in the stars, and you can have an expectation of how long it'll take you to strike oil in that position, how much oil is there. No, natural gas, how much natural gas is there, and um, yeah, the time it'll take you to reach that natural gas, and at the depth it is, the natural gas is present. So that's some visualizations just using Spotfire, and like I said, background R, Iron, Python, JavaScript, and feature extraction is the second part. So now that you have selected the features that you need to be analyzed, so now it's to extract valuable information. And hopefully with this extraction, you can even dwindle the features down a little more. And there are different types. So uh, these are not all the types. These are some types that I think that are most important for everybody to know. That's the principal component analysis, random components, independent component analysis, linear discriminant analysis, and principal component. I will start with that. So principal component analysis, what it does is, when two variables, more variables are related, what it does is it takes the most variance using the least squares, it takes the most variance out of those variables and places them into what is now referred to as a component or a uh, product of two variables. And we've actually been over a reason for principal component analysis in one of our previous lectures, right? So this is a good example of just looking at the correlation between two variables. So what you have here is you have what's called multicollinearity. So you have a relationship between two of your features that is very, very correlated. And when you have that, it can throw off the analysis because only one feature is actually needed, or only the variance between what is going on here is actually needed. So that's what principal component analysis does. Is if there are multiple features like this. So for this example, I have tricep and thigh, but many times there are relationships between variables, uh, multiple variables, and just one or two components will better explain those variables as opposed to using the many variables. So using two components, that's a feature that dwindles the features down. So if there are 5 different variables that could be related, such as maybe the body mass index, the amount of fat a person has, though, and the tricep, thigh fat, all those things are heavily related. Using one or two components, maybe one component dwindles those 4 variables into one variable, and that better helps analysis. And this is dimensionality reduction method, transforming large variables, small one, step-by-step explanation. Uh, the use looking at the mathematics will pretty much help you just understand what's the advantages, disadvantages of using this. But just besides looking at the mathematics, it's not important. Understanding when to use this and why it is necessary is most important, more important. Random component analysis is the second one. No. Okay, it's called random projection. I call it random component analysis because everything else is analysis of components. But what we do instead of a principal component analysis, which may take longer and more computationally expensive, what you have is you have a random projection on a high dimensional data space into a lower subspace. And it's supposed to have been found to be computationally efficient and more accurate, but not and almost as accurate as a principal component analysis method. And this paper shows different sets of data that have been used and have been shown that taking these random components as opposed to finding the principal components has little to no effect on the overall analysis. Quite quite frankly, it's at your discretion if you want to use random, any of these, but I would more stick with principal components. Um, you have independent component analysis, and what that does is independent component analysis basically uh, thinks of the variables as a mixture of actual independent components. So what you have is the variable and you have the independent components, and you want to do is what you want to try is you want to try to get this matrix A with in using I guess analysis and trying to find the results you use a matrix, but you want to get the A and the S's as far as this, and this is yeah. So you want to get this matrix A and all the S's, which are the actual independent components you're looking for. And problems that would be used for this would be, when people looking at brain patterns and trying to figure out, what the brain is doing at a particular time, and how these components will affect that. And uh, another problem is the cocktail party problem, where you have two speakers speaking at the same time. You want to determine, through the MP3 recording and the different wavelengths and whatnot, exactly which speaker is which, right? So you want to filter out all the noise and be left with the component that is most necessary. And so that's also, this is why this is also a dimensionality reduction technique. And there is a very good chart. This is page 30 and 31. Give it some time. Okay. It's loading slow. So, okay. All right. So here is a example that much better visualizes. So what you have is you have two different components in this example, but what you are given as far as a data set is a product of those components. As you can see, the first one more heavily matches, well, this one right here more heavily matches the first one, but it's a product of these two, right? So you do see it going down and still have the wave lift, then coming up. And so it's a product of these two actual components. And that's what you were given as far as a variable. And this one as well, as you can see, this one is more prevalent, but it still is a product of these two actual components. And that's what you were given as far as a variable. And what you want to do is you want to take this and get it back down to these two components for analysis. So the components in this case will be a lot more helpful in the analysis, right? So splitting what the actual speaker is saying from the background noise in the cocktail party problem, or finding the places in the brain that, when they are, well, the patterns in the brain that are most important. These types of things are used for independent component analysis. Did I do everything? Linear discriminant. So what linear discriminant does is, as opposed to principal component finding the maximum variance between multiple variables, linear discriminant finds the biggest distance between two variables. So it is also a technique that is used for unsupervised learning, but it also can maximize separation between variables as well. All right. So it's we have feature selection, we have feature extraction, and feature transformation. Now, feature transformation, actually, we have discussed feature transformation previously during other webinars, right? So what are the reasons for feature transformation? So to provide each variable equal chance to impact the model. So once you have your components, once you have your features that you're going to use, you want to provide these features and variables an equal chance. So normalization, standardization, right? Get the values between 0 and 1, or a zero mean with a 1 deviation for all variables. Just depending on the type of problem. And all these are done in previous webinars and Udacity videos. And you've also had to do them for your supervised learning project and deep learning project. And the reason why we do this is because a feature with a higher variance could have a much greater impact in the model just based on the higher variance, and the different means can cause dramatic fluctuations in the weights and make the model harder to train. So this is why we um, have, get the means and get the ranges of the features we're looking at in junction with one another. And so that's and also for model assumptions. So in for most continuous models, one big assumption that you most often see is that the features or the population which the different features are taken from, is normally distributed. So you would think that the being normally distributed, you need to look at the features, right? Explore the features, make sure that you have normally distributed features. And if not, then you must perform some types of transformations on them or possibly remove the features from analysis. And, like we've been over before, there's different transformations, and the ways you can observe these transformations are also in a previous paper that I have shared as well. Whether you need a logarithmic, exponential, sinusoidal, um, the inverse, the square root, whatever it is, the features you need. A previous webinar showed exactly through instead of visualizations. Of course, visualizations of the eye is definitely tricked in a lot of cases. The previous webinar did show you different ways to perform metrics to uh, understand which transformation you need at the particular time. And another reason for feature transformation is the model requirements, right? So if you have a continuous model and you have categorical data, right, you cannot use categories such as male, female, race. Those are categories that you are trying to input into your model. And one way to um, use categories or make categories available is to do one-hot encoding. And one-hot encoding is something that was done in the supervised learning project, definitely, and something that is taught in the Udacity videos as well. So one-hot encoding takes a variable such as race that may have maybe four different categories: black, white, Asian, other, and then from those categories, it would then take that one variable and split it into four different categories, and then give it a 0 or 1 based on whether it is a part of that whether it is a part of that value or not. So that is going categorical data into continuous models and continuous data into categorical models. If you are using a categorical model and you do have continuous data, then one thing that can help is separating into bins, right? So uh, different histogram analysis and looking at how the variables are better, looking at how the feature is better separated, right? So if you have a feature and just let's say maybe three bins, you just look at how it is different as opposed to the uh, observations within the bins that are so I mean, just using different amounts of bins, just 3, 4, 5, 6, 7, 8, 9, 10, and separating and seeing which one looks better, which one fits better for your model. And once you separate those into bins, then you could then use the continuous data in the categorical model. So uh, that is pretty much it as far as dimensionality reduction, right? So first you select the features based on what you explore and visualize from the data, your domain knowledge, your intuition. And once you have those features, then if you need to extract different components from those features, then extract the components from the features, and that will dwindle the amount of features even further. And then once that is done, then based on the model that you will be using, then you want to transform these features to be better able to help in the model and to clear all assumptions and all requirements that the model may or may not have, and also allow the features to impact the model with equal opportunity. So that is um, pretty much it for all of the dimensionality reduction, and also principal component analysis was covered inside of the dimensionality reduction. And for afterthoughts, so I would like everyone to meet with me during Tuesday. Well, this is when I usually I'm waiting for my face to pop up. All right. So that is it for dimensionality reduction and principal component analysis. I would like everybody to meet with me Tuesday or Wednesday of next week. There are many people that I would like to try to get a coordinated how we're going to complete the first project and the second project and move on to the third project. For the ones who completed the first project, we need to coordinate how we're going to complete the second project and move towards the third project. And for the guys that who have completed the second project, just getting a great chart on making sure we complete the third project is would be helpful as well, right? So looking forward to hearing from everybody on Tuesday or Wednesday. Um, I will send an email as well, requesting that everybody meet me on Tuesday or Wednesday. So for the next week, I would like you to try to catch up, complete the second project. I will be given a calendar, a better metric on what we need to be doing next week, because you have different people that are at different phases of this program now. So hopefully we'll be able to talk through and develop a calendar and a schedule on what we're going to complete on what days uh, for each person. And all right, is it for this webinar. Are there any questions? If there are any questions, please post the questions in Slack or post the questions in the group chat for the YouTube video. If I do not see them in the group chat in the YouTube video, I will try to post it in Slack as well. I've not seen anything in the um, group chat before, but I've seen questions that appear on Slack. So just hoping, whatever questions may arise, I'm able to see and answer those questions. Also, I know this is at 3 in the morning for you guys that are on the East Coast of the States. You realize the reason why I'm doing this is because I'm in a different time zone at this point, and the people that I was staying with, I did not want to bother them and talk through this webinar at 2 o'clock in the morning. So this is why it is done this way. But you can, this is on YouTube, so everybody can go back and look at this at whatever time of the day they would like. And if they have any questions, they can then ask me on they can then ask me on the Slack channel or during our meeting on Tuesday or Wednesday. Okay. So we're at 10:43. I will give it another 3 minutes or so, and hopefully I get responses generated by then. One thing that I do not see is I do not see enough questions or chatter in the Slack channels. And I would, not be worried if everybody was on pace or close to on pace. But what we are witnessing now is we have many students who are not on pace, not having completed the first project when we are more than 2/3 of the way done, and um, having not completed the first project, I would assume that there would be questions that need to be answered, but I do not see any questions need to be answered. So hopefully, I do see questions. And since nobody has, look at Slack. All right, no. All right, I do not see any questions. Okay, so that will be it. I will conclude the webinar. We'll give it a couple of more, give it a minute or so. Wait till 10:46. It's 10:46. All right. Do not see any more questions. Um, I hope these webinars be more of a Q&A as far as question and answers that I can help with. But seeing as hopefully you're looking at this at different times than on live, but that will be it as far as the webinar. Thank you. Peace.